Hello, grade 12. Let's have a look to lesson 5 from term 2 revision. Okay, we're going to be looking at one question. We're going to be doing probably more videos, but let's have a look to activity 1. All right, now this activity 1 might be a little bit long, so I'm going to divide it in 2 videos. I don't want to make videos too long because they become big and might be too long. Okay, it's tiring and use a lot of data. So I'm going to do activity 1 and I'm going to divide it in probably 2 videos. We're going to do 1.1 first and 1.2, and then in another video we'll do the rest of the question. Okay, so let's read the question. Let's start by reading the question. The question said a block of 85 kilograms start moving from rest under the action of a force of magnitude 240 Newton. Before go on, let's look here. Starting from rest means that the initial velocity is equal to 0. Okay? Alright. Under the action of a force of magnitude 240 Newton that forms an angle of 20 degrees with the horizontal. The coefficient of kinetic friction is 0,2 and the block moves a distance of 8 meters. Before we go on, let's draw a small sketch of the situation of this problem. Okay, so we have a surface. We have a horizontal surface, and right on that surface, the surface is rough. Let's do these lines to know that it's a surface. On that surface, you have a block. There is a block on the surface. It's not floating, it's on the surface. And there is a force acting on that block, an applied force. This block is, the mass of the block is 85 kilograms. Let's write it here. Oh, that color is not a good color. Let's get another. Let's try this one. Is 85 kilograms. And there is a force of magnitude 240 that acts on the block, and that force makes an angle of 20 degrees with the horizontal. This is the applied force, and it's equal to 240 Newton. Right? That makes an angle of 20 degrees with the horizontal. If this is the horizontal, this angle here is 20 degrees. Okay, this is the angle of inclination. That one there. Now there is friction. There is friction opposing the motion of the object. This is a frictional force in opposite direction to which the object is moving. Now here, let's see what other information is given apart from those two forces. There we know that the kinetic coefficient of friction is 0,2. We have that the displacement of the object is equal to 8 meters. And that is all the information that is given to us. Okay? So we have the kinetic coefficient of friction. We have the displacement. Let's write here that the initial velocity is equal to 0. It might be helpful later on. Okay? So now this is the first 2 steps. To have a rough sketch of the situation, it will help us to understand better, and to write the data. This it will save us time later on. The next step to me is a very, very important step, and that is the free body diagram. So let's draw the axis. I like to draw the axis. However, in the x-axis, I'm not going to write x-axis. I am going to write displacement, because the object is moving across or along the x-axis. And this one will help us to find out what is the angle between the forces and the displacement. Remember, we need that one when calculating work. Okay, this one is the y-axis. Right in the origin is the body, the object, the block. And then let's see what forces are acting on that block. Okay, so now what forces are acting there? First of all, we have the applied force. Remember, it makes an angle of inclination, have an angle with the horizontal. This is the applied force. I'm not going to write the value. This is the small angle that we need a little bit later. What other forces are acting there? Frictional force in opposite direction to which, opposite direction of the motion. The force in that direction to the left. We have the gravitational force. This in this case is downward, weight. And then we have the normal force. Remember, normal force is the force from which, or the force from the surface on the object, and that force must be perpendicular to the surface. Those are the forces that act on the object. Now, If you notice, the applied force is in none of the axes. It's not in X, it's not in Y. Therefore, you learn in grade 11 on previous grades that you have to determine or resolve this one into two components. You have here the parallel component of the applied force, also called the applied force in X. And this one, if you go to the angle, which is this one here, 20 degree, is the adjacent side to that angle. Therefore, will be equal to the product of the applied force by the cosine of 20 degree. Here, you do the same in the y-axis. You project that force into the y-axis. There will be the applied force in y. And then the applied force in y, if you come here, this is the y, the applied force in y, which is equal to this one. And therefore, is the opposite side to the angle. This one will be equal to the applied force multiplied by the sine of 20 degree. Right? So this is the free body diagram, and we already solved the applied force in two components because it is in none of the axes. Now we have all the information, we have the data, we have the free body diagram. Now we are ready to go and start solving the problem. So let's go to 1.1. Right. So 1.1 said calculate the work done by the pulling force. Okay. So we go to the definition of work. Question 1.1. Remember that work done by a force is equal to the product of the force. In this situation is the applied force multiplied by the displacement multiplied by the cosine of the angle between the applied force and the displacement. Okay, so if you go to the free body diagram of the situation, the displacement is here, the angle between the applied force and the displacement, which is the x-axis, is at 20 degree. There you can see it. Okay, so all we have to do is substitute because everything is given to us. The applied force is equal to 240. 240, there is the data. So it's the product of 240 multiplied by the displacement, which is 8, multiplied by the cosine of 20 degree. Okay, so let's go to our calculator here so you can see the product. So it's 240 times 8 times cosine of 20 degree. That gives us an answer equal to 1804,2983. So we're going to round off to two decimal places, and that will be 1804,21. All right, so the answer is 1804,21 joules. That is the answer for 1.1. Right, let's go to 1.2. 1.2 is a question a little bit tricky because we have to use or make use of Newton's law done in previous grades, in grade 11 or other grades. Okay, so this is 1.2, and let's go to the question 1.2. Now in 1.2 they said calculate the work done by the kinetic frictional force. So let's start by writing the formula needed to calculate the work done by the frictional force. So the work done by the frictional force is equal to frictional force multiplied by displacement multiplied by the cosine of theta, the angle between displacement and force and displacement. All right, so if we go here to the sketch, it cannot be green, otherwise we're going to get confused. Let's get this color. So the displacement is seen in the x-axis and the frictional force is there. Remember, so the angle will be from here, from the x-axis, all the way down there. That is the angle, and you can see it's 180 degrees. So the angle between the force, which is the frictional force, and the displacement is 180 degrees. So let's write here, right next to it, theta is equal to 180 degrees. Remember, cosine of 180 is minus 1. Okay, now what is the problem? Where the problems come in this question? Okay, the problem comes when we don't have the frictional force. We don't know how much is frictional force. Now, in previous grade, you learned that frictional force is equal to the product of the kinetic coefficient of friction multiplied by the normal. this is the formula we're going to use to calculate frictional force. However, there's still problem. Why? Okay, we don't have the normal. So we have to get the normal first. All right. Now, for the normal, to get the normal, we are going to go back to the free body diagram. In what axis is the normal force? Well, normal force is in the y-axis. Is that correct? What are the forces are in the y-axis? You have normal, you have the applied force in y, and you have the gravitational force. Okay, those are the forces that you have in the y-axis. All right, if we go here, you can see, I'm going to mark here the y-axis. This is the y-axis, and those are the forces that are acting on the y-axis. Now, note the following, and it is very, very important. The object is not moving in the y-axis. It's moving across the horizontal surface. So, in the y-axis, if the object is not moving, the acceleration is zero, as well as the velocity. Okay? So, we are going to use Newton's second law. I'm going to write here in y-axis. Why? Because we are going to work in the y-axis, because the normal force is in the y-axis. And because these are forces which are vector quantities, I'm going to write upward positive. I'm going to write up positive. The upward direction is going to be the positive one. So we're going to apply Newton's first law. Remember, Newton's first law states that if no net force acts on an object, or the forces are at equilibrium, the object remains at rest or moving with constant velocity. So net force is equal to 0. This is Newton's first law. All right, Newton's first law of motion. Now, what forces? Net force is the vector addition of all the forces that act on the object, but we are in the y-axis. So we go to the y-axis. What forces we have? Normal, applied force in y. Both of them are pointing upward, and therefore they are positive. And we have the gravitational force pointing downward, therefore is negative. So we have normal plus applied force in y minus gravitational force is equal to 0. We are looking for normal. Don't forget that one. So we can substitute the formula for the applied force in y and the gravitational force. Okay? And we can rearrange the equation here. So we have that normal is equal to gravitational force is going to the other side positive minus the applied force in the y-axis. Okay? If we go on substituting here, the formula for gravitational force is the product of the mass of the object times the acceleration due to gravity and the applied force in y. Remember, we have it here. There is the applied force in the y-axis. That is the product of the applied force multiplied by the sine of theta. So let's substitute the values. So the mass of the object is 85 kilograms. Acceleration due to gravity is 9,8 minus applied force is 240 sine of 20 degrees. Let's take this one and move it a little bit here, just to fit. Okay, sine of take off that one. That is right here. Sine of 20 degrees. Remember, it's the inclination. We have here the angle. Okay, so we are there. Now all we have to do is the calculation. We're going to do the calculation in part. Let's divide the calculation in part. So let's first have the product of 85 times 9,8. Let's go here to our calculator. Is 85 times 9,8. That is equal to 833. So it's 833 minus. Now we're going to the product of 240 sine 20. Okay, so it's 240 multiplied by sine of 20. And that's giving us 82,0848. We're going to round off to 2 decimal places, which is 82,08. 82,08. Okay, so it's 82, 0.8. All right, so now let's subtract those values there. Okay, let's subtract the values. We have 833. Sorry, 833. Let me just show you. It's 833 minus 82.08. Right? 833 minus 82.08. And that gives me 750.92. 750.92 joules. All right, so let's substitute the normal here into the equation of frictional force. Okay, let's go back to the color that we were using for frictional force. So this answer here of normal must go in there. So frictional force is equal to kinetic coefficient of friction is 0.2. Let me just show you the data here. 0.2 multiplied by the normal, which was calculated 750.92 joule. 750.92. Right? So the frictional force will be equal to, let's go to the calculator so you can see the calculations. So it's 750.92 times 0.2. This is a frictional force, a normal force, was calculated multiplied by the kinetic coefficient of friction. The answer is 150.184. Let's go to leave it like that. 150.184 Newton. There we go. All right, and now the frictional force is going to be substituted in the formula of work. Remember, the main question is to calculate the work done by frictional force. All right, so this frictional force we calculate is going to be substituted in the formula of work. So let's go here and let's rewrite the formula of work just so you remember. Work done by frictional force is equal to frictional force multiplied by displacement multiplied by the cosine of 180 degree. All right, remember it's negative. So the answer here is frictional force is 150.184 multiplied by the displacement, which is 8, multiplied by -1. Let's write -1, which is cosine of 180. So let's get the calculation here. The calculation here is 150.184 multiplied by 8 multiplied by -1. Every number multiplied by 1 is the same number, and negative because positive times negative is negative. So the answer is 1201.472. Let's round off to 2 decimal places, okay? The final answer. So the final answer is 1201.47. That will be joules. This is the work done by frictional force. So in this question we cover 1.1, which was calculating the work done by the applied force, and then 1.2, which was calculating the work done by the frictional force. Next time I'm going to make a video to finish 1.3 to 1.5. I don't want to make the videos too long, and the video is already 19 minutes. Okay, thank you very much. I hope you understand. We're going to continue with this question in the other video. Okay, thank you very much.